Good morning, Machalog. In today's video, I will be talking to you about a very interesting question that was asked in previous years in J Advanced. If we have a basic understanding of capacitor chapter, then definitely we can dive directly into this video and understand the multiple layers and multiple depths of the concept that were used in this question. First of all, let's understand the question. At time t equals to 0, the terminal A is connected to terminal B. So this is the diagram that was given to us in the question, and the A terminal was connected to the B terminal. This implies that the circuit is currently in an AC position. In an AC position. Current through this AC circuit, through this AC source that was being transferred in this circuit is given to us by this equation, that is I naught cos omega t, where I naught is the maximum current, that is 1 ampere, and omega is 500 radian per second. That is also the information that is given to us. While looking at this question in J Advanced, we should write the given information that I have written here so that nothing from the question misses out as we read it. Second information that was given to us is the initial direction of the current is shown in the figure. So the direction that is shown to us is the initial direction of the current. What does this imply? Let's say if this is the initial direction of the current, definitely the capacitor is being charged, and the current definitely comes from the positive direct terminal, that is the higher potential, and goes towards the lower potential, therefore charging the capacitor's upper plate positively, therefore charging the capacitor's lower plate negatively. All right. At time t equals to 7 pi by 6 omega, the key is switched from B to D, particularly at this point of time. At 7 pi by 6 omega, the switch was shifted to AD position. B to D, from B to D position, from B to D position. A total charge of Q flows from the battery after it was shifted. After it was shifted, this circuit can be removed, and the only circuit that the capacitor is now connected to is with the battery. And during that connection, a total charge of Q flows from the battery. So we have to determine the value of Q. All right. But to determine the value of Q, we must first understand what was the initial charge that it was carrying. What was the initial charge that it was carrying from the previous circuit? From the previous circuit, it was carrying some charge. After it was connected to the battery gave it some more charge. That value is Q. So we have to find Q. There were multiple options in this question. We will be solving each option one by one, understanding the depths of this question. So first option that was given to us was to find the magnitude of maximum charge on the capacitor before t is equals to 7 pi by 6 omega. So before t is equals to 7 pi by 6 omega, the capacitor was connected to this circuit. Again, before t is equals to 7 pi by 6 omega, the capacitor was connected to this circuit, due to which it might have been getting charged. And during this charging process, the maximum charge is what is asked to us in the question through this option. This option tells us that the magnitude of the maximum charge on the capacitor before this time is this. So we will have to check whether this option is correct or not. First of all, the current equation is given to us. Can we determine a charge equation in this circuit? Definitely. We know that dq by dt is nothing but current. Replacing the current with the equation of the current that is given to us in the question, the AC source is supplying this much current with respect to time. So I can be written as I naught cos omega t dq and dot dt, right? Initially the charge is 0. Finally, at any time t, let's suppose the charge is q. So at time 0 the charge is 0. At any time t, let's suppose the charge is q. Putting these limits in the integrands, we will get q is equals to I naught sine omega t by omega this value. Am I right? Is this correct? This is absolutely correct. Q at any time t in the circuit will be equal to this value, where definitely I naught by omega term, where definitely I naught by omega term, if sine omega t becomes 1, if sine in this equation, if this value of sine omega t becomes 1, definitely the I naught by omega term is the maximum value of the charge, is the maximum value of the charge. So this is what is asked to us in the question. Let's put the values there and check if it is equal to 1 into 10 to the power minus 3 coulomb or not. First of all, I naught is given to us as 1 ampere. So Q naught, that is the maximum value of the charge, it can be written as I naught by omega. I naught is given to us as 1 ampere and omega is 500 radian. Multiplying the denominator and as well as the numerator with 2, we will get an equation that is 2 into 10 to the power minus 3 coulomb. So this is the maximum charge that is stored in the circuit. And particularly, this charge is stored in the circuit at what time? Let's analyze it. Particularly, the time that corresponds, that is such that makes the sine omega t term 1, we will have to get that particular time. So sine omega t is equals to 1. This would imply that t must have been pi by 2 into omega. This must imply that time must have been pi by 2 into omega. And at this particular time, the charge must have been 2 into 10 to the power minus 3 coulomb. The charge must have been 2 into 10 to the power minus 3 coulomb. Now, this part, we must have written this part. Let's move forward and analyze the time and the charge that is given to us in the option from the answer that we got through the solution. dq by dt is I. So particularly at t is equals to pi by 2 omega, the charge is maximum. And at this point of time, the maximum charge is nothing but 2 into 10 to the power minus 3 coulomb. The question that is asked to us is whether before 7 pi by 6 omega, the magnitude of maximum charge is 1 into 10 power minus 3 coulomb or not. So at t is equals to 7 pi by 6 omega, at t less than equals to 7 pi by 6 omega is the maximum charge 1 into 10 to the power minus 3 coulomb. Understand things very carefully that 7 pi by 6 omega, we have to analyze whether this particular time lies before this or after this. If this particular time lies before this, that implies that the maximum charge will be equal to this. So pi by 2 omega into 3 into 3. This would give me 3 pi by 6 omega. 3 pi by 6 omega. And 3 pi by 6 omega is definitely less than 7 pi by 6 omega. This particular time must have occurred before this time. And at this particular time, the maximum charge is 2 into 10 to the power minus 3. Therefore, The maximum charge before 7 before time 7 pi by 6 omega is 2 into 10 to the power minus 3 coulomb, perfectly at 3 pi by 6 omega at time equals to 3 pi by 6 omega. Therefore, this option is not correct. Therefore, this option is not correct. The maximum charge is 2 into 10 power minus 3. The option is given to us as 1 into 10 power minus 3. Just wrong. Moving on to the next option. Moving on with the next option. The next option says that the current in the left part of the circuit, the left part, this part, just before t is equals to 7 pi by 6 omega, perfectly just before t is equals to 7 pi by 6 omega, the switch is still connected with B. So before this time, is the current, is it clockwise, is it clockwise? Let's analyze whether it is clockwise or not. I is equals to I naught into cos omega t, where I naught is the maximum amplitude of the current, that is 1 ampere. Cos omega t, that is 500 radian per second, into time, perfectly just before t is equal to 7 pi by 6 omega. To determine the current at this particular time, we can put the time as 7 pi by 6 omega. That is nothing but pi plus pi by 6 into omega. Omega will cancel this term and we will get a equation such which looks something like this. So cos pi plus pi by 6, cos pi plus pi by 6. Particularly this value will be cos pi by 6, but in the third quadrant, that makes cos negative. So current at particularly at this point of time is minus half ampere. What does this imply? Initially, initially the current is in this direction, and this direction implies a positive current. This direction is particularly a clockwise direction. This direction is particularly a clockwise direction. If we are getting a negative current, then definitely the current now at this particular time when the current is negative, the current is anti-clockwise. The current is just reverse of the positive assumption. The positive assumption that the current will move clockwise would imply that the negative current definitely move in the anti-clockwise direction. That is what is happening here, particularly at this point of time. Therefore this option is also wrong. Current implies that it is in the anti-clockwise direction. Particularly at this point of time, if the current is negative, the current must have this direction, and this arrow represents an anti-clockwise moment, an anti-clockwise current. Therefore, this option will also be a wrong option, right? It is, let's say, a scenario is given to us where the current is clockwise. In this particular scenario, if clockwise is taken positive, the anti-clockwise will definitely be negative. Initially, the direction of current was clockwise. Initially the time was 0. So putting t is equals to 0. The current at that particular time will be equals to positive I naught. Definitely the question wants us to take clockwise direction as positive current. Whenever I get a negative current, I would conclude that the direction was anti-clockwise. Is this clear? This must have been very clear to all of you. Let's move on to the next option. Let's analyze the next option, that is the third option, immediately after A is connected to D. So now this part's role is over, and we have connected A to D. So the new circuit would become resistance R, and resistance R is given to us as 10 ohm. Particularly at the time when we connected A to D, before that it was charging due to this particular plate. And the charge that is stored to in this circuit can be determined by the equation that we derived earlier, that Q is equals to I naught by omega into sine omega t. So particularly at t is equals to 7 pi by 6 omega, when the switch is connected from B to D position, when the switch is changed from B to D position, particularly at that time, what is the charge in the capacitor? 1 by 500 into sine omega into 7 pi by 6 omega. At t is equals to 7 pi by 6 omega, charge q on the capacitor 1 by 500 into sine of pi plus pi by 6. Pi plus pi by 6 is a third quadrant. Huh? So charge is equals to 2 into 10 to the power minus 3. This part becomes 2 into 10 to the power minus 3 into sine pi by 6, that is sine pi by 6, that is half. Alright. So this is nothing but 1 into 10 to the power minus 3 coulomb. This is nothing but minus half. This is nothing but minus 1 into 10 to the power minus 3 coulomb. So this would imply that the lower plate, the upper plate that will be negatively charged, the lower plate will be positively charged, and the exact charge value will be 1 into 10 to the power minus 3 coulomb. So Q is equals to 1 into 10 to the power minus 3 coulomb. Just after this time, the switch was connected from A to D. Before this time, the charge that must have flown to the capacitor is equals to 1 into 10 to the power minus 3. All right. In the third option, we have been asked. To calculate the current through the resistance immediately after A is connected to D. है कि नहीं? So after A is connected to D, the current through this I is what we have to determine. Applying KVL, we have to apply KVL, as after connecting, this capacitor also has some charge. It is also supplying some charge to the resistor, due to which there is current through the resistor. This battery also supplying some current, that is therefore there will be current due to battery through this resistor. To calculate the net current, we will have to apply KVL, Kirchhoff voltage law, starting our loop in this direction. Let's say the current was flowing through the circuit, that is equals to I. This 50 will be positive plus. We are moving from the negative plate to the positive plate. So the final plate is positive, that is change in potential, that is the change in potential will be positive Q by C. And the resistance, we are moving through the resistance in the direction of the current, and we know that we often take this potential as minus IR in this scenario when the current and the direction of the motion is same. Putting the values that we obtained earlier, we will get 50 plus 1 into 10 to the power minus 3 by C is given to us as 20 microfarad, that is 20 into 10 to the power minus 6 minus I into resistance is given to us as 10 ohm is equals to 0. What will this become? 20 plus, this will be 10 to the power 3 by 20, and this will again be 50 minus I into 10 equals to 0. So 0, 0, 0 cancels out and I becomes 10 ampere. Definitely this option is absolutely correct. The immediate current A, when A is connected to D, the current in the resistance is 10 ampere. That is a very accurate option as we calculated and we got the current value as 10 ampere. Definitely this is a correct option. We could, if we would have corrected this option, this question would have been very. Looking at the final option is the option that we where we have to calculate the charge that must have flown through due to from this battery to the capacitor. Initially we discussed this, that when the circuit was connected to from A to D, definitely battery supplies some charge to the capacitor to fully charge it, and that is the charge that is given to us as Q. We have been said in the last option that check whether this Q value is 2 into 10 power minus 3 coulomb or not. Let's analyze this option. After A is connected to D, just after A is connected to D, we know that the upper plate had negative charges and the lower plate had positive charges. Exactly the charge was 1 into 10 power minus 3 coulomb as we discussed in the previous option. After this, the battery is connected. Battery connection will act in the circuit and supply some charge Q to the circuit, and it will supply this charge until and unless the potential across this capacitor is equal to potential across this battery. So finally, till when, till when, or till which point of time will the charging continue until the potential across the capacitor is equals to the potential across the battery. So finally, when the circuit has reached equilibrium and all the charges that must have been passed from the battery to the capacitor has passed, finally the circuit would look something like this. And finally, it would have a potential that is equal to 50 volt. So if VC is 50 volt, definitely it now has Q final, it now has charge equal to 50 into 20 microfarad. And this will give me 1 into 10 power minus 3 coulomb. 1 into 10 power minus 3 coulomb. Initially it had minus 1 into 10 power minus 3 coulomb. Total charge that the battery must have supplied is the difference of this charge. So the battery provided the charge, extra charge, that is equals to Q final minus Q initial. Finally, we wanted the capacitor to have this charge. Initially, the capacitor had this charge. This much amount of extra charge must have been provided by the battery. So this is equals to Q. And Q final is 1 into 10 power minus 3 coulomb minus, initially it was negatively charged. So minus of 1 into 10 power minus 3. This will give me 2 into 10 power minus 3 as the value of the charge that must have supplied from the battery to the capacitor. That is the D option, and D option is absolutely correct. Observe very carefully that how we decided that the charge is negative and not positive. Finally, we want the capacitor's upper plate to have a positive charge, and because it has initially a negative charge, battery must first provide this much amount of charge to make this part equal to 0, after which it again charges it to make it positive. So it supplies a double amount of charge first to make it initially to make it negative to 0, then from 0 to positive, negative to 0, negative to 0, then 0 to positive. So there was some charge supplied here, there was some charge supplied here, and total charge is the charge that we have to calculate. Total charge is the charge that is supplied by the battery throughout the process throughout the process in the capacitor to make it in a equilibrium state. In this particular video, we understood multiple concepts of capacitor. If we had some basic idea, definitely this must have enhanced our ability of solving questions and understanding the deeper meaning, deeper charge distribution, deeper deeper arrangement of the methods of solving the question. So keep studying, keep exploring, keep asking me doubts. We will meet in the next video.